Introduction. Welcome to our educational series on construction materials. In today's episode, we'll shed light on lightweight concrete, or LWC. So, let's dive right in. Description. Section 03320, Lightweight Concrete Part 1, General. Before we delve into the details, let's start with the basics. 1.01 Description. Lightweight concrete, often referred to as LWC, is a specialized type of concrete that finds its place in various construction applications. But what exactly is it, and where do we primarily use it? LWC is typically used to fill over structural slabs, offering varying thicknesses and slopes as dictated by the project's requirements. Areas where lightweight concrete is used. Now, let's explore the areas where lightweight concrete is frequently employed. Building roofs. Building roofs are a common application for lightweight concrete. Its reduced density makes it ideal for providing insulation while not imposing excessive loads on the structure. Floor and ceiling systems. Lightweight concrete is often used in floor and ceiling systems. It enhances thermal and acoustic properties without adding significant weight. Bridge decks. In bridge construction, especially for longer spans, lightweight concrete helps reduce the overall weight, making it an excellent choice for bridge decks. Tunnel linings. Tunnel linings benefit from lightweight concrete due to its ease of installation and ability to provide fire resistance while maintaining structural integrity. Thermal insulation. Lightweight concrete is a preferred material for thermal insulation, particularly in cold storage facilities, as it offers both insulation and load-bearing capabilities. Fireproofing. Its fire-resistant properties make lightweight concrete a valuable choice for fireproofing applications, such as in industrial settings. Exterior cladding. When used as exterior cladding, it provides both insulation and aesthetic appeal, making buildings more energy efficient. Stadium seating. In stadium construction, lightweight concrete can be used for seating areas, ensuring comfort without compromising on structural strength. High-rise buildings. In high-rise buildings, where weight management is critical, lightweight concrete is used to achieve the desired insulation and fire protection while keeping the structure within acceptable load limits. Residential construction. Even in residential construction, lightweight concrete finds its place, improving energy efficiency and providing a comfortable living environment. The components of lightweight concrete. The components of lightweight concrete. To understand lightweight concrete better, let's take a closer look at its key components and the ratios involved. Materials. The materials used in lightweight concrete include a Portland cement, ASTM C150, Type I, non-staining. Portland cement, it meets ASTM C150 standards and is typically of Type I, which is non-staining. Lightweight aggregate, ASTM C330, Group I, perlite or vermiculite or other processed natural material required by manufacturer. Lightweight aggregate, this meets ASTM C330 standards, falling into Group I, and is typically made from materials like perlite, vermiculite, or other processed natural materials, as required by the manufacturer. Fine aggregate, ASTM C33, natural sand. Fine aggregate, it complies with ASTM C33 standards and is often natural sand. Water, clean, fresh, and free of harmful matter such as oil, salts, acids, alkali, sewage, deleterious minerals, or organic matter. Water, the water used should be clean, fresh, and free of contaminants like oil, salts, acids, alkali, sewage, harmful minerals, or organic matter. Air entrainment agent, ASTM C260, type recommended by lightweight aggregate manufacturer. Air entrainment agent, this agent adheres to ASTM C260 standards and is recommended by the lightweight aggregate manufacturer. The mix design. Now, let's discuss the mix design, which is crucial in determining the characteristics of lightweight concrete. A. Properties of mix. Adjustments are made to achieve the specified properties, including characteristic cube strength, 150 kg/cm2 minimum, at 28 days unless otherwise indicated on drawings. Characteristic cube strength, typically, a minimum strength of 150 kg per square centimeter is targeted, achieved within 28 days unless otherwise specified. Slump, 75 mm maximum. Slump, the concrete should have a maximum slump of 75 mm. Air entrainment, 3% minimum, 5% maximum. Air entrainment, it should contain a minimum of 3% and a maximum of 5% entrained air. Execution. With a solid understanding of the materials and mix design, let's move on to the execution phase. General. Before commencing work, a thorough examination of the substrate is imperative. Unsatisfactory conditions must be rectified before proceeding. Preparation. Adequate preparation involves cleaning and, when necessary, roughening the base surface. Ensuring proper bonding is critical for the longevity of lightweight concrete. Reinforcement. Reinforcement plays a crucial role in ensuring the structural integrity of lightweight concrete. Here's what you need to know. Comply with ACI SP66, ACI Detailing Manual. General requirements: follow the guidelines outlined in the ACI Detailing Manual, SP66, for proper reinforcement practices. This manual provides essential details on reinforcement placement, including spacing, bar size, and cover requirements. Installation procedure. Let's dive into the installation process of lightweight concrete, which involves several critical steps. Slurry deck surface. Slurry deck surface. Begin by preparing the deck surface. This often involves the application of a slurry, a thin mixture of cement and water, to enhance adhesion. Place insulation. Place insulation. Install insulation material over the prepared surface. The insulation helps improve thermal properties, essential for energy-efficient construction. Achieve desired thickness. Achieve desired thickness. Ensure that you achieve the specified thickness of the lightweight concrete. This thickness is typically a minimum of 50 mm, 2 inches. Slope for drainage. Slope for drainage. Depending on the project requirements, slope the lightweight concrete to facilitate proper drainage. This is especially important for roof applications. Curing details. Proper curing is essential to maximize the performance and durability of lightweight concrete. Here's what you should consider. Protect from moisture loss. Protect from moisture loss. It's crucial to shield the newly placed lightweight concrete from excessive moisture loss, especially in hot and dry conditions. This can be done by covering it with wet burlap, plastic sheeting, or applying curing compounds. Hydration facilitation. Hydration facilitation. In low humidity conditions, consider sprinkling water over the concrete surface. This aids in the hydration process, ensuring the concrete achieves its desired strength. Testing after pouring. Testing after pouring. After pouring lightweight concrete, it's essential to conduct several tests to verify its quality and performance. Here are the key tests. Compressive strength test. Compressive strength test. This test determines the concrete's ability to withstand axial loads. Samples of the concrete are taken, and their compressive strength is measured. The specified strength, often 150 kg per square centimeter, must be achieved within the designated time frame, usually 28 days. Slump test. Slump test. The slump test assesses the consistency and workability of the concrete mix. A slump cone is filled with concrete, and the cone is then removed, measuring the slump or drop in height. It ensures that the concrete has the desired workability for placement. Air entrainment test. Air entrainment test. This test measures the amount of air trapped within the concrete. It's crucial in ensuring the concrete's durability, especially in freezing and thawing conditions. The air content should fall within the specified range, typically 3 to 5%. Conclusion. End of section. With these reinforcement, installation, curing, and testing details, we conclude Part 1, General of our exploration into lightweight concrete. In the upcoming episodes, we'll delve deeper into its properties, applications, and benefits. So, stay tuned for more insights into this remarkable construction material. www.techdosengineering.com/upcoming videos yet to release